All right, lesson 10, 9, numbering from 0. We need to talk about veins of Eyre and Iris. So we're going to talk about Urbit as a personal server, right? This has been the branding that's been adopted from time to time. I think it does a moderately good job of communicating what that is if you're really familiar with what a server is. And that's actually terrible for communicating to normies in a sense, right? Like you're going to Twitter and you're saying Urbit's a personal server. Like, what does that mean to people? There have been a lot of different kinds of models out there for how do you operate client server pattern. And one of the most interesting, I think, is the sun computing sun rays, where you'd have this thin client that would basically hook up to a monitor somewhere, and you'd have this persistent session somewhere in the background. And what would happen is you'd go up to any terminal and you would have this smart card, and you'd plug this smart card into the thin client, and then you were immediately logged into I guess you had a password too, but then you're immediately connected to the persistent session that's running somewhere else. I got to use one of those for a little bit at Los Alamos a while back, and those are pretty fun, but I'm not sure if anyone really does those anymore. I think Urbit actually gets like really close to that vision where, you can access it through any front end, and it persists that for you. So, okay, anyway, back to server stuff. So generally speaking, right, when we say we have a server, we mean a server is something that serves a service. Right, it's the locus of computation, it's the coordination process, it's how we put all these things together, and it basically runs as a system daemon. Urbit's execution model fits this niche nicely, as long as we're sort of essentially willing to graduate all of the nodes in our network to being both clients and servers, that they're both acting in this way. So it's not the radial wheel-like client server model that you're used to on the web. It's this, federated, right? Like it's distributed in a certain way. So there are a lot of things we run that are servers, right? We run web pages, HTTP. Most frequently, we often run application servers, even if we're not actively thinking of them as servers. We're often running software processes on the same hardware the local network as a client processor. We do this with mail servers, with print servers, file servers, all act this way. There's a lot of times that you have software that, even though it may not actually be running as something that is formally considered a server, it is behaving as if it is a server. Even if you did fully decentralized Git, you would still be, in a sense, pretending, feigning that what you have is a server. Eyre and Iris are the parts of Urbit that act as HTTP servers. So these are the web page-like components of what's going on with Urbit. If we're going to talk about HTTP requests, then it's like a Gall agent poke. It's a message to trigger some action on the server with a GET, a PUT, or a POST, and then there's this associated service-specific data, payload that's with it. So you send a header, a request header, and then information header, and then a body payload. And so in some ways, it looks a little bit like the AIMS stuff that we were looking at with UDP and the AIMS package last time. Let me switch to a screen I can type with. Here. Okay. All right. So HTTP, sorry, this is, let me clear up some screen real estate. Okay. Is this text large enough, or would it be better if it were larger?
A little bit larger would be nice.
Okay. One of the features that I wish Urbit could do this, but unfortunately it doesn't control the windowing system, is that it would automatically remember configurations. Every time I switch to Zoom, I don't have to rearrange literally everything on my screen. All right, let's see. Okay, Eyre, Iris. All right, so HTTP requests. You have a request header. This has information like host and user agent, which is typically the browser that you're referring to. It has MIME type information here. It can have locale and encoding info located as well. Then there's information about like, how do you want to keep your connection? You want to keep your connection alive? What do you want to do with HTTP versus HTTPS? All these components. Anyway, and then ultimately there's a type, right? Like there's a kind of request that you're going to put there. You're gonna be sending. So a get is like a peek. A put is put and post get used kind of similar to each other. They're both analogous to Urbit pokes, but it's basically state creation or update, like change something that you already have. And then a post is a request to process data. These get used a little bit interchangeably on the web in practice, but these are the kinds of things that we have to be able to deal with. One of the differences with get, right, is that there's no bound namespace. So every time you run a get, you could get different information back out. That's actually one of the things that Xanadu was also trying to deal with. If you go look at Ted Nelson's old project, it's like, how do you deal with persistence of information on the web? So Eyre and Iris, as HTTP server client veins, have to be able to deal with requests and responses. So Eyre has to be able to receive requests and produce responses. Iris has to be able to receive responses and produce requests. Iris is not heavily used. We're not going to spend a whole lot of time on it. It's actually a pretty simple vein at this point, but Eyre is also not that complicated when it comes down to it. A lot of state handling, but not nearly as involved as what we saw with AIMS, for instance. All right, and then HTTP response are the thing we're going to be sending back, and this is a code. All right, so classically, 404 means you're missing, 200 means okay, and then there's a whole bunch of other ones. It's actually pretty interesting to go look at what all of your options are. One of the interesting ones that I've been thinking about experimenting with once we implement some payment processing infrastructure on Urbit, whether the token stuff that we're thinking of that Tiller and I have been talking about doing or otherwise, is implementing 402, which is payment missing or payment requested, I think. And then this has been experimental on the web, but the problem has been is there hasn't really been like a good lingua franca for how do you, like, what does it mean to have a payment request to access a resource? But that's something else that we can play with there. Very commonly, you'll run into 500s, which are like server internal error. It means you've got a connection, but the server is processing things in a weird way. Most recently, I ran into this on Urbit when we got the cards out of order and we were kicking responses before we sent the value. So for 500 just means something's gone wrong, but you can't tell from the client end what that looks like there. Tiller, I was just commenting on server response codes. When we implement the token stuff, we should take a look at doing the 402 response and put in a handler for that, just to make that a little more interesting. All right. From Urbit's perspective, there's really two parts that we have to be able to handle if we are going to communicate mechanically with something. Eyre, we're going to be doing some manual bindings, dealing with things with Eyre that actually does the processing for things. And then we're also going to use a lib server to wrap a lot of the common kinds of responses, do the construction of the HTTP response, and so forth. Your general use pattern for Eyre and Iris. You don't do a whole lot through the kernel with Eyre or Iris. I suspect this is kind of one of the reasons these are actually simple veins. It's because they don't touch the kernel a whole lot. You do use them with glob HTTP requests where you need to figure out, what does my front end look like. Other than that, Eyre as a server is largely just actually receiving the response, unwrapping it in whatever shape it needs to, and then handing it to you as an inbound server request to Gall, or it's wrapping your outbound server response from Gall. So your use pattern is very commonly going to be, you have an agent. In your on poke, you're going to receive HTTP requests. And the most common pattern is to have a handle HTTP arm that's going to deal with the inbound request error values. You've probably seen this type, for instance, and you have to unpack and see, is it a get, is it a put, is it a post? How am I going to process this information? And then libserver has request header parsers and response handlers that make it much easier to figure out what's going on. So for instance, with that, you might end up using commands that would look like this. It automatically handles the authentication. If you're not authed in, then it knows how to handle the redirect and everything. You don't have to think mechanically about what's going on with that. Okay, so Eyre, at the level we're dealing with Eyre right now, we are going to take a look at the runtime side of this, but the level we're dealing with, Eyre is going to receive HTTP messages from Unix, and it's going to produce HTTP messages that it's going to pass back out. An agent can register endpoints. You've seen cards that look something like you end up doing like these dap.bol kinds of things like this, and then you have to handle a value back out. You can also use Eyre with generators and with threads. This is a lot less common. I feel like advertising using Eyre with generators was a thing we promoted in the Urbit sphere in like 2018, 2019, probably because that's the era when the serverless processes like AWS Lambda were more popular. And I feel like they haven't really, the ability's there, but we don't actually sort of like highlight that we can use this nearly as much as we used to. Thank you. And the ability to run a thread, unfortunately, looks quite different from the ability to run a generator because you're actually poking into Spider and running things manually that way. So we'll take a look at both of those as well. So if Eyre can get responses, let's talk about if a request is coming into Eyre first and what that does, and then we'll go back and we'll start actually looking at code with LOL and Eyre and everything. All right. So what I said there was a post, a put, and a get. All right. Eyre, by convention, only uses post for one thing. In Eyre, that means get a cookie. It doesn't mean that you can't do other things with post in your apps. It just means that this is what we're actually running into when we use this with Eyre. And so you end up with statements that look like this. So in this case, we're going to post with the known less code password to login, and post a little header here. Or no, sorry, this is a response, and this is a response we get back as a 204 OK. and it gives us this set cookie that we can decide how we want to unpack it or whatever we have. I don't remember if the semicolon is considered part of the cookie or not. Probably, but most of the time this stuff gets wrapped by JavaScript. I actually often, because I really hate trying to figure out how to do things in JavaScript, I often just use curl when I'm trying to test things and make sure that things are responding the way they're supposed to. So this is kind of more my space here. All right, so for post, that's all you're going to do. All right, so a put sends an action to Eyre. So this would be a poke, a subscription, an ACK, an unsubscribe request, channel deletion, other kinds of things. You're asking Eyre to update or change its state. And then a get is used to connect to a channel and receive events. So this is kind of similar to on watch functionality when you send these gets up front. Hey Matt, how you doing? All right.
Happy dentist.
Eyre is fairly long, as you can see here. To start off with at the beginning, let me actually, I have a refactored version of this. I think it's a little bit easier to read. Well, it's a little bit easier to read if I can fit it across. There's a way to switch off word wrap, Alt-C. Okay. All right. So the first part that we're interested in here, we can ignore this cache stuff actually. For right now, we don't need to worry about that. Gifts and tasks, right? The kinds of things that we can do with Eyre. One of the reasons that the Eyre interface is fairly complicated is Eyre is going to handle a few things as a server. It's going to handle authentication. It's going to take care of channels, and we'll talk about exactly what we mean by channels, but channels are sort of the JavaScript equivalent of subscriptions, right? That we're maintaining open, the ability to communicate here. Threads and generators, which, as I said, have different interfaces, so there's some overhead for dealing with both of those. Finally, HTTP requests. And then there's things like the scry interface that expose the internals of this. And so there's a dispatch system in action, which is going to push these around. Let's see if action is referred to in any of those. No. Let's go to lull. All right, there's our action dispatcher here. So when a incoming request is matched to a binding, you'll notice we have to have a binding, which is this mapping we're going to maintain between a path to some sort of resource. It's unique for the system. Right now, a binding takes place where we just manually specify, like I said here, where we just pick a name and we bind to that name. So rumors and pals has a different binding scheme than like the Twan stuff that uses app. Right now, this is wide open, and you can do essentially anything you want to with these connections. And people have even experimented with, what happens if you bind SIG, for instance, like what happens if you just try to override the default handler and so forth. In the future, I think the thing that's most likely going to happen is we're going to start binding within subdomains. And so you'll bind, but essentially this will be probably not your agent. It'll be your desk, but I don't remember what the shorthand for a desk is. I guess it'd be shipped on Arbo.net network, whatever this ends up looking like that. And then you'd be allowed to bind paths to agents below that point. And so that'll be a little bit more hygienic than what we have right now, but no one's using it maliciously at this point. So we're currently okay. So actions are bound to endpoints and then get dispatched in particular ways. Most of the time, Eyre is going to wrap all of this and you don't need to sort of explicitly think about it. You just know that there's a channel system. Things are going to come in to what you have, or you're binding to a particular application, and Eyre is taking care of this for you. Hold on, lol, I want here. All right. So within the overhead of these 5 things that Eyre has to keep track of here, some of the stuff is configuration or session management. You'll notice that the way that sessions are currently managed is pretty basic, right? We maintain a set of authentication cookies. And if you provide a cookie that is in that set, then you have a valid session. There has been some discussion about upgrading this so that we're actually trying to map things we know about clients to cookies, which, arguably makes it a little bit more secure than it is currently. You can get a response. You can get a binding notification back. Like, do you know that things have been bound correctly? And they may not, right? So when you handle these and you're on Arvo arm, you may have to deal with the case that a binding was rejected for some reason, which would typically mean something else has bound it. And then a lot of different kinds of tasks that are going on here. Buck-Gar is a rune that's been turning up more and more in LoL as we move deeper down into the veins. I don't think Bane really used it. Ames used it a couple times. Here we're marking a lot of things with it. We do it with other things like Ames tasks and Dill tasks and so forth too. But this basically lets us import the set of vein tasks that match a current pattern to put those in. Then we have configuration, what we're looking at for rules, for requests, for connections, etc. Nothing fancy there. I'm actually curious with code changed. Let's take a look at this in a minute. If changing our code wipes our previously existing sessions or not, right? Does that actually clear our cookies? Or are old cookies still accepted at that point? Would be worth knowing. Then there's a fair amount of core stuff that we're going to deal with here. This is a cross-origin request something. I don't remember what the S stands for there. Basically, these are conflicts you get when you're trying to serve resources that have multiple origins within a single application, and you have to do some explicit handling if you want to permit that. I've only run into this once with building applications with Eyre. When I was trying to serve, I was working on an application where I had parts of it I was serving from an Urbit ship and parts of it were communicating with an Earth-side server. And I ran into some core stuff then, but other than that, there's a hood generator that you can use to manually approve these things, and then you don't have to worry about them. Yeah, let's see. I guess request and request local are kind of where these values come in. Okay. Let's look at bindings then. All right, so we're gonna set a binding. We're gonna have a system unique mapping for a path, and it's gonna bind it to a particular, like, you're gonna have the set of bindings, and then you're gonna be able to use these bindings to dispatch to actions. Is the pattern here, as I said. And so when we dispatch a binding, we actually have this as a unit because it's either the identity site or we've manually mapped in an actual domain that we want all of this to work through. Not really, other than, when you set up a site conventionally, there's not really any action item here, just that these things actually exist. And then there's a path that refers to that particular binding. And then in Eyre's internal state, it's going to maintain a list of bindings, which are going to be in bindings. Yeah. So it's a list finding a duct and an action with a binding path. There's actually an interesting consequence of this here. So the fact that we're specifying the site at the domain here at the top with the path means that in principle, we can actually handle multiple top level domains. And this might be prefatory to being able to do subdomains there. But anyway, it looks like formally in an Urbit server, if you could figure out how to get the DNS configuration, everything set up, it would be able to handle multiple TLDs. Then you've got your regular, you deal with this stuff all the time in Urbit where you have things that are cached, where it would probably be nice to go back and cache these in the runtime. But right now we cache them in Hoon and let them live there. Yeah, Matt, would caching URLs be able to give us a good speed up at bindings for just doing GET requests? I don't know how much load we're really taking on a conventional Urbit ship from HTTP requests at the end of the day, so that may not actually be a huge speed up, but yeah, we keep track of ports, we keep track of ducts, and the way all these things are. Oh, Matt's at the dentist, so that means he's got someone working on his mouth right now. All right. Let's see, sysvein Eyre. Okay, top level before we get into particular. What I'm going to do next is I'm going to talk through these tasks. Like, what do these tasks actually look like? Honestly, we're probably going to be done in 90 minutes today. There's not a whole lot to say about Eyre and Iris other than just introducing these components here. What I do want to look at though is the top level structure, which means if we go look at like, what's a take or a load. All right, so there's only one. And in this case, it's doing the same thing as Ames did, where we kind of have these gross previous states of everything. What I actually find really fascinating is the way that we're storing these old state transition functions is actually against the types that we have presented here. So on dates, so kind of an interesting carryover there. Anyway, there's only one interface arm that we don't have any of like the larval stage and the mature stage or any of that business with this. It's all just pretty much here. It's pretty much straightforward. I mean, like the stay, like like you have your load stay pair where you invase things. Ultra simple there. Your scries are pretty straightforward there. Let's actually look at scries briefly because I'm here before we get back and look at authentication. Let me get a terminal going. See if I have a Zod. Okay. Let me jump to my scry notes. All right. So we're looking at what the scry actually exposes here. Coming down to your main wet less. All right, all the veins expose a way, which is essentially the weight of your memory pressure at this point. Like, what are all the things that you're doing right now? Then there's a lot of cross-origin request stuff that's included there. Whether or not cookies are authenticated, we can find this information, whether or not, what's in our cache, what are our current bindings and so forth. So, this is a fake SOD that I have here, hasn't been running for too long, but there are some, so I've started the debug server. So the debug server is available here. It looks like Dill, probably through WebTerm, has some endpoints registered there. Some login channel stuff, Spider ready to go. Lure gets registered. Apps gets registered to Docket, so it can do the redirect to what they're now calling landscape, if I'm up to date on that. And you can grab other things like authentication state. In this case, I don't have any cookies. There are no active cookies, so there's nothing to say about the sessions that are out there. So if I come back out here and I run the curl to get a cookie. All right, now I have a cookie. So if I go back here and I run authentication state again, now I have a cookie with an expiry that is, I guess I'm 5 hours off Greenwich mean. So that's, I guess it's good for 1 hour before that comes back to me. As far as the scry interface goes, that's pretty much it. There's really nothing else there. Does give you some information about fake versus real, which is interesting. This is one of the first places that we've sort of explicitly managed this. So like with AIMS, I think when we talked about AIMS, I actually just sort of skipped over what happens if you have a fake ship versus a real ship. With the boot sequence, we talked about it some. But here we actually have to deal with, we're defining our local host binding versus looking up, do we actually have something else? Do we have access to HTTPS and all this other stuff? Now let's go back up to authentication. Authentication state. Okay, so the way this is typically used is you're going to look up your information, has by sessions authentication state.state candidate, right? Like, is your cookie, okay, this is a collision right here. So this is checking, making sure that we aren't colliding on our cookie generation. But functionally, this is what we're doing is we're adding the cookie, we're returning this back out, and then later on, whenever we get a request to authenticate, we're going to be checking whether or not this cookie is present there. LOL actually has the authentication state definition, which is simply a map of PAT-UV, which are cookies, to session info. And a session is that info that we saw right here. We check this. Okay, so expiry and channels that are associated with it. Right now, I don't have any channels. I did this at the CLI. I don't have any JavaScript channels that are associated with this, so I can't do anything with it. The other state. You know what? I am in. Let me check out status. Or what do we call it in status is Aries. What do we call it in there or in Urbit?
What do we call what? Sorry.
The main branch, but not the develop.
Develop? Oh yeah.
Okay, what I want to show you is this is actually changed. Authentication state has changed. Okay, what's added to authentication state? What wasn't there before?
Oh, visitors?
Visitors. Okay. So this is the EOS fake session stuff where you can log in as a comment from a browser and see what's going on. And so this has all been added in. We'll talk a little bit more about this session in a minute, but now what we're doing is we have a regular session that's tracking things, but we also have a concept where we need to treat someone as a fake comment that's generated and thrown away for that one session. So there's some things that have modified there. Yeah, the rest of this is pretty much the same. Authentication is handled by authentication. All right. So this is one of those engine arms. And what this is going to do is it's going to check the kinds of things you can do. So you're gonna run it through a handle request, and it's going to actually check and see, do I know, is this in my field of known cookies? Return our login page if we need to. Excuse me. Okay, here's the EAuth stuff that got added in 4.13. I don't really know of, so Mark had a web page that was demoing a public group chat in groups that it would do the EAuth, and you could just go to a browser page and talk to everyone directly through the browser page without doing any login, which was an interesting concept. But other than that, I'm not sure if there are any applications that are showing this off right now. I don't know. Has anyone messed with fake logins yet? Okay. And then I want to take a look at request is logged in. All right. So this is how we're actually checking if we have the ability to do something. Okay, interesting. So EAuth might be getting, I don't know, you think that's getting firewalled somewhere? What he says is, for posterity, Chiller says, I wasn't able to get EAuth working on my DigitalOcean hosted ship. Okay, I guess we don't know why, but might be some work to do there. One of the options for the homework this time would involve writing something that uses EAuth, but all right. So what we're doing here, we're going to check request is logged in. We're simply checking if our session ID, the information that we have, our cookie and everything is correct, and if we are within the expiration time. And if both of those are the case, then we are logged in. There's also a request is authenticated piece here that's checking this same kind of information here. But again, like, this is really straightforward bits and pieces here. Yeah. All right. Channels. Okay. So on the the JavaScript side, you have certainly seen, if you've looked at it, it'll start talking about event source channels if you're using the Urbit HTTP stuff. And an event source is a channel. It's the way that a web page is going to communicate with a Gall app. Basically, an event source channel so event source is an API that basically numbers events, and so it allows your server to push individual events to the browser over a connection that you want. If you reconnect, then you're going to send a last event ID so that you can recover and then resend all events since then. So My guess is that the on watch logic was actually modeled on event source. We'd probably have to look at exact dates of when these things became well defined and known, but it's very similar to the pattern of on watch and dealing with on kick and on resubscribe, you know, the resubscription and everything. So essentially, event source defines an interface that allows your client to track server sent events. And so you'll see SSE referred to in some of the JavaScript stuff. So that's a server sent event. It's going to receive those as text FAS event stream formatted events. So you're going to provide it with a connection ID, the next sequence number, you know, the next event that you need to send, the last time you had a live connection, all that kind of stuff. This is probably in LOL. Okay, so there's a lot going on in here. Let's start with, okay, so SSE wants a heartbeat. It wants a periodic check-in, so you have connection. Subscriptions are mapping your channel information and your subscriptions to each other, so you can keep track of everything that the open channel knows about. Like aims, where we have to keep track of what we know we've sent and what we've dropped or unsent yet, we're going to do unact. This is actually going to be used in practice to decide whether or not to keep. There's an algorithm that uses this and last acknowledge, last act that decides whether or not to close the client session. You know, it's going to expire at some point. We keep track of all the events, so we have a queue of events that we need to send to the client from the server. Again, very Ames-like, you know, pretty straightforward here. Last act, last connection, next ID, what's the next number we need to use as we're sequentially identifying things. A state, which is going to keep track of, you know, like, do you have a timer on a duct? Like, are you keeping track of what's going on with this? And then finally, up at the top, we have identity, which is, you know, basic information about who you're connected to. Then there's this really interesting one here. This was added in 4.12 or 4.13. I forget which one we put this in. But this mode is what lets us decide between, is this a noun channel or a conventional regular channel? So like a regular channel is going to be sending JSON over the wire. If you have a value passed into Urbit, then it can be sent through a mark to be grown or grabbed into a noun or whatever other type you have. You can do the same transformation on the other side to get it back into a MIME type wrapped in a JSON, but conventionally it always communicated in JSON. That's just simply what your browser spoke. Now what happens is we can choose if we're going to send JSON or we're going to do a noun channel. Noun channels do make it possible for us to speak Urbit nouns with external applications over these EP channels. There's not really much that does it, and we have things like lick that also let you speak nouns, or you can do the newt based noun communication, the ivory pill ghost ship stuff. But it's an option here if we have things that do know how to communicate in Urbit nouns. Now I wanted to trace what happens with a poke. All right, so we're going to get a poke. It's going to be a poke or a poke JSON. Let me find the one that I'm looking for here where it comes in. It's a poke ACK. It's a heartbeat. I don't want that. Okay, this one. All right. So poke is one of the things you can do over channel. You can poke an application, and this is going to be a noun against mark. So this is your noun channel look. The other option is a poke JSON, which is your JSON option, and it's going to run it through the mark. This is why it's automatically taking care of the mark transformation when it pulls that in. And so if we go to poke JSON, yeah, here's the mark stuff where it's saying, go ahead and pull this stuff in, figure out how to do that transformation and pull that back out. Functionally, this is the way it's wrapping that information there. It's actually not really talking to Clay directly. The mark stuff, the mark transformation is taking place under the hood rather than explicitly, even within Eyre. But this is the place where we get that set up. So we have both of those kinds of things. Let's also look at I'm going to add a folder to my workspace here, because I want to also look at Yard, because Yard has a lot of examples that we can use to talk about this. Okay, I'm pretty sure this isn't actually my copy of Yard, but I have something that is called Yard, so it's odd. All right, let's see. I'm looking at lib schooner here. All right, so when we have something come in, when we have something come in, it's a resource, it has a MIME type associated with it. And almost all of Urbit tends to treat MIME types as chords, as what MIME types rather perversely called octs, OCTS, but are bytes, right? 8-bit bytes instead of, I don't know where the ox thing came from. It's probably like how we call it a word, and it varies depending on the system that you're on. But anyway, it's an oct. It's an 8-bit type. In practice, this means that almost everything that we're communicating in an atom, which in some cases, like JSON, means that is a, well, yeah, I mean, it's an octet stream, but I don't know why they don't just call it a byte stream, is what I'm saying, like why they're using octet versus byte. Since functionally a byte is always 8 bits, but anyway, a few of these are tape, which means that they're actually stored as the list of bytes, or some other type which automatically gets processed, but more commonly it's an atom. And in cases like a PDF or an audio file, it means that what you're transmitting is just very simply bytes. You're treating it as a binary stream of values here. In some other cases like XML, SVJ, it's a chord, right? Like it is a stream of bytes, but those bytes actually do just resolve very directly to text containing that representation there. What this means is that when you do these conversions here, we actually have to convert, we have to make sure that the MIME type is in the correct kind of thing. In this case, we're sort of unwrapping it into a list of values, returning a unit, and then adding an HTTP status and some header that has, in this case, content type connected to it in order to serve that value back out there. So this is sort of directly handling the representation here rather than doing a mark-based transformation at this point. However, we can also do the mark-based stuff, which we need, in fact, to even represent such a file on Clay. So let's look at FLAC. Right, so FLAC doesn't really need anything. It just needs, there's a mime grow arm that has the right identifier on the front. And then in this case, make sure that it is converted to binary values going out. And if we're going to try and grab it through the mime, then we're gonna grab it this way through the tail there. All of these functionally are going to look the same in that regard. It's basically wrapping a header and then giving you a byte stream, octet stream back out on the other end there. So resource provision along a channel is reasonably straightforward in that way. There's also an interesting one where when we do something along a channel and it is a noun, it's a jammed noun, what we're checking here, this time we're doing the fine channel mode, but we're saying, is this a xurb jam? If this is a JSON value, or sorry, a jam value, right? So this is a jammed noun. So we automatically get this xurb jam stuff put on there when we send something in. This is the mime type, the custom mime type that we can enforce in these cases here. And I think these are the only places we use. Actually, the noun mark has this as well. Let me find that. The noun mark is sort of like this gloriously complex file in that it does nothing. I'm not thinking of noun. I'm thinking of which one am I thinking of? Maybe it was just JSON. No. One of these is really complicated. That's okay. It doesn't matter right now. What matters right now is that the mime type that it's going to serve when it produces these, this automatically, when you pass it in as a mime type, then it's going to give you the xurb jam with the jammed noun as your byte stream out there. Now I'm noticing something interesting, which is, no, okay, we're consistent there. We are application. It's the extended channel format has the X custom modifier on it, but otherwise we are doing xurb jam out. Since mime types and marks have almost a one-to-one correspondence, it's interesting that we actually don't have an xurb. And we do have a jam. Yeah, I guess that's just implicitly handling this. Oh wow, look at that. Haven't seen clam in the wild in a long time. So all right, so that's the xurb jam stuff, noun channel stuff. Again, like there's actually not really anything special about noun channels. The implementation is pretty simple. This goes back to Urbit in a sense doesn't know about UDP, right? The runtime knows about UDP and communicates in UDP, but Arvo doesn't. Arvo doesn't care. Similarly here, if we wanted to have Eyre speak something that wasn't JSON and wasn't a jam, all you'd really have to do is check all the places where xurb jam or poke or those related pieces are stored, and just do something that's completely analogous to those in order to pull that around. So on Urbit's side, it's pretty straightforward. On the other side, if you want something that speaks nouns or whatever else you're doing, you need to find something like noun.py or so forth to handle that. All right. This has been hinting towards, this is our header stuff. Now we're actually ready to talk about HTTP requests, which is the real purpose of Eyre. Like the thing Eyre does as an HTTP server is speak HTTP requests and responses. So Eyre itself maintains a server configuration. It has a little bit of state, but not a whole lot of state. That's fine. Bindings is probably the right place to. Yeah, so there's list of active connections, list of domains that we know about, list of ports, HTTP stuff. HTTP config in LOL has the RSA info. If you're HTTPS, it has your TCP proxy, how to deal with 301 redirects if you're going to upgrade to HTTPS and so forth. There are HTTP rules that it cares about somewhere here. Maybe it only cares about it in the actions. It's probably in bold then. Yeah, so there, do you have a certificate? Do you have a DNS binding that you know about? Pretty straightforward. Addresses are, again, pretty straightforward. IPv4, IPv6. This last one, this line 2513 with Ames Pat P is really intriguing to me. And I don't know if this just represents like some wishful thinking down the road or exactly what this would look like. I've asked, but I haven't gotten a response for like sort of where that is, but maybe that points to some future hopeful promises there. All right, and then finally, inbound request. This is the thing that you're actually processing when you do this manually in Gall and so forth, and the request itself. Most of the time, the only things you're going to check is, are you authenticated? And then you're gonna process the request inside of a Gall agent, because not all Gall agents care if you're authenticated, right? There are Gall agents that just very straightforwardly will let you, at least view some resources without authenticating. In Eyre, all of this goes through the HTTP arm. But I want the type first. Yeah, here's the type. All right, so all the methods that we know about. If it's not in this list, we don't have it. So what kind of thing is this?
Well, it's a constant chord, right?
Yeah, it's a constant chord, which is kind of an odd one. Okay, there we go. What is that?
That's because this is a PAT-TA, right? So it does not render the uppercase.
This is a case where there's actually, it's not even a PAT-TA thing, actually. It's just in general. You can't, there's a special notation internally that is like unspeakably ancient. You can write cells this weird way. You can write values this weird way. It's really opaque. It's not documented anywhere, but the parser and the pretty printer know how to do these representations of values back and forth like this, where you're actually storing the hex of the ASCII characters across. Actually, I'm not sure if that's hex. That might just That's not hex. That's just maybe that is hex. Anyway, there's this whole weird set of chord representation that lets you do these direct values here. Like I say, it's not documented anywhere. The only place I've really run into it being a problem is if you are trying to create a new atom aura, you have to find something that doesn't collide with existing atom auras. And it turns out that this notation squats on a whole lot of aura configuration space, like the way that you might want to represent things are captured by this weird notation here. So it's in there anyway. So yes, this is a constant chord that we've run into here. All right. So what is a request? A request is an incoming value. It has a method. It has a URL. It has a header list, and then it has the payload that's accepted with it. Response headers gives you a status code and headers and everything. That's request. There's response header. I think there's another response one too. Okay, yeah, and then there's simple payload. Simple payload is the one that you're going to use most of the time if you're in user space. So this is your quote simple one event response. Like generators produce these, but other things in Hoon produce these as well. Schooner likes these. Rudder, I believe, uses these in a couple places. So this is your response header and your payload. It's your header payload. Pretty straightforward. Really easy to go ahead and use. And it is what libserver is built to work with. So when you are passing things out from libserver, it's going to be passing things around with everything. So like libserver has these arms like require authorization, where you pass it the inbound request, the handler, and it's going to return a response here. And the response might be, here's your value. And the response might be, if you are authenticated, then you can just handle inbound requests. You don't have to do anything else with it. But it checks, and otherwise it does a redirect and binds it so you're able to get back in. Yeah, request those kinds of things. Yeah, so simple payloads, what gets used in all of these values here. I think HTML response is what Schooner ends up using when it unwraps everything. Yeah, so this is kind of a simpler version of what Schooner seeks to do in a much more elaborate way. So these wrapper arms can be nice. Parse request line is one I've used a couple times. Most of the time, the authorization stuff is the main thing that I use, and I use libschooner instead of these on my responses there. Yeah, as far as HTTP handling goes, does it even refer to, yeah, so this does refer to simple payload. Okay, so when it actually builds, this is like your cache request, but it's a good example of like what does a value look like. It's just gonna put your handle response, which is gonna build your header, and then put these values together and send it back for you. All right, let's look at what a generator looks like. So threads and generators. All right. We have to register with serve to bind a generator at a path. Having done that, then we're able to hit that path and, you know, actually produce some value there. The generator, what is a generator is, it's a desk, it's a path to the actual generator, and it's the args that you expect in. This is important here. We can kind of treat this like an AWS Lambda where we have a serverless thing where we can just run this generator, but we're going to require the generator to be on the current ship and, you know, just provide that to you. I'm also not clear on if these must be naked generators or if you can do, say, generators with these. Ask generators don't really make sense because you have to do them interactively. But I think we're actually like pretty limited in what we can do with generators just by what generators are. You know, naked generator doesn't do a whole lot for you. It's just a gate that does that calculation for you. So this is used to run generators over HTTP, yes. However, the generators have to return a simple payload. So for instance, this is an example from the docs here where, okay, so it looks like we are actually, it is like a say generator. It's not a say generator in that it is returning you a say pair the way that Dojo expects. It looks like it's just its own kind of generator, but that you are automatically supplying in now any beak the way you would with a say generator. Like I say, aside from one tutorial, this is like now basically not documented and not, to my knowledge, really used. But I think it's an interesting bit of functionality we actually could start employing again. Yeah, do you need to be authenticated, etc. All right, you're going to return a simple payload. And at the end of the day, that means, in this case, we're returning some value, and then we're returning a 200 with the value here. Let's actually run this. Let me call this AirGen. Let's actually see if this works for us. If we haven't done things that will change. Oh no. Well, shoot. Oh no, it's okay. It's okay. I have a change in Iris. Okay, all right, all right. No, what happened was I was experimenting with Iris and I made a change to Iris and then I reverted that change. But then when I did the checkout, when I did the checkout, it reverted the change, but it didn't force a rebuild of my desk. So okay, all right, fantastic. All right, so what I need to do then is I need to bind it, which I can do with a pass card like this. All right, and then I should be able to put some kind of why is this? Okay. So I'm running on 8080. I bound my gen. I'm going to send it some data. Let's see if it actually, okay. So it did accept that and then just spit the data back out to me with the timestamp. So just as plain text, that's all it takes. That's all it does. I don't know. It seems like it is potentially useful for putting these things together. Now, threads are going to be more complicated here. And what you end up actually doing is creating a binding from Eyre to Spider at a particular thread path. And so we actually need to go look at Spider to see what that looks like. Because now Spider has the handle HTTP request arm here. And so if you've bound to Spider, you assert that you're authenticated, so you can only run these authenticated. And then you're going to assert that you have this information. You have a desk, you have an input mark, you have a thread path, you have an output mark, and you have a thread ID. No, you're not providing a thread ID. If someone wants a really easy fix, like an easy PR, converting this to use pull not instead of this I.T.T.T.T.T stuff would be really nice. And so, yeah, this is just going to give you the regular thread interface is available to you here. Does it deal with arguments? I don't.
You have to
I
probably
guess it
control
does here, doesn't it? Sorry, what's that?
that for that URL thing parsed and see if there's any information that used elsewhere. Oh yeah, the inbound request itself. That looks like it might be.
Yeah, it's in the body. It's in the request body is where the args actually get passed in. Then okay, and then you unwrap everything. We're actually in base mode here to build that because we're reproducing what Dojo does automatically. So building the vase that Dojo does it wraps every time it does a thread input, and then explicitly constructs the start args and then starts that thread with libio stuff there. Mikolai says, what's the alternative to unpack the list elements again? So what you would do is, right now this is a tuple. What you would do instead is you would do something like this. And then you could give it name faces like this. And then you'd be able to do desk site URL to refer to them. And it just saves you this nonsense here in working with that. But I don't want to do it live because then I would spend at least 5 minutes debugging it. But it's a really quick fix, and it would actually make this more legible than it currently is. Anyway, there's a fully worked guide on both generators and threads. If you're interested in using either of those, they're there. But from a Core Academy perspective, we're kind of more interested in like how did these actually get instrumented, which is what you've seen here doing this. Let's see, what else does Eyre do? It has the EAuth system, which is it's how HTTP clients authenticate themselves as a specific commit on an HTTP endpoint. We looked a little bit at that. One of the questions was, how robust to collision is random EAuth assignment? Right. So, if we have, if we're assigning a random commit to a client session and it's kind of it's a fake commit, not a real commit. Does that work? Can we actually do that? So what we could say is I guess that would be POW 2 to the 128 minus 1. So that's about 1 in 100 billion, trillion, quadrillion, quintillion, undecillion. That's 1 in 10 to the 40. So, you know, I don't think we're gonna get a collision there. It's probably better than a lot of hash tables, to be honest. So it does seem safe to just do EOTH and randomly assign comments to client sessions and not worry about the fact that they're not really keyed.
The next step is to have commits to your own user ID system, so you can have a forum hosted on your Urbit without the need for Urbit ID. Trent, make it happen.
Well, inspired by, I think it was you, were you, I think it was you that was talking about having username password login.
Yes.
Okay, that's the homework.
Is it really?
Yeah.
Lol. Okay. Sorry, guys. I'm like the nerd teacher. You forgot to assign us homework.
Yeah. There's SSL stuff, like Acme. I think Acme is like not the one we're supposed to use now. I forget what the current state of all this stuff is. I think there's a different one we're supposed to use now, but this still does it. But you know, if you want to send uses the engine pattern, so you have to worry about this with your list of cards and everything. But basically, it emits a pass to install to Arvo to set up a rule with the certificate that you provide to permit SSL, HTTPS connections there. Yeah, we already talked about the scry interface. So like from the Arvo side, that's Eyre. There's not really a whole lot else to say about Eyre. On the runtime side now, there's more going on. Maybe, I mean, I say there's more going on. There's still not a lot going on because HTTP is just kind of a library thing where you're just making sure everything is the right shape and you're passing it through to something to make a decision with it. Yeah, it is. It just calls to, there's a library called H2O, which is an HTTP server. And let's see, I'm not jetting. I guess I'm not even downing.
You want to go in the, it's not going to be in the package at all.
It's IO. No,
It's
well, I
IO.
mean,
Oh.
it's
Oh yeah. I think you're looking at
HTTP.
H2O.
No, yeah, because
Yeah.
H2O is
It's
I guess we statically link it because we statically link everything, but
it's going to be in one of your Bazel things. Yeah.
yeah. Yeah, basically you start your server, yeah, this is like, do I have the right string? Unpack the string, make sure that it's the right shape of things. A lot of this is just manually, like I've received a thing. I have my libuv loop with a callback. And once I get something in my libuv callback round robin, then I just keep looking for everything and coming back around till I actually run my callback functions. Yeah, so Sidnime says, what's the difference between HTTP and CTTP? Basically, HTTP is Eyre, it's the server part, and then CTTP is the client. That's Iris part, which we haven't looked at yet, but we will take a look. There's I think they spell it weird. Yeah, so like there's the callback. So this is where something's actually going to come in. It's gonna hit here. And if we can actually process the thing, then it's going to go into accept the HTTP connection and open things up. And then this is where H2O library comes in. The H2O is going to handle, okay, I'm going to make a socket. I'm going to accept values over this socket. I'm going to pass these values around. That's the server setup. Then there's another one that is sequence accept that handles the actual request when the request comes in. So that's like your channel. Serve accept is like your channel setup, and then now you have your sequence accept, which is your HTTP request. Presumably things are well formatted in that they're, once they come in over HTTP, like even to be transmitted, they have to have like a certain kind of look to them. And then it does a manual check on, is this actually the right kind of thing? Text event stream is what the event stream channel stuff looks like. And then start responding, 200, we're open, we're good, we're able to do things here. There's hgen send. This is what actually sends sends your response values there, and you have queues and breakdowns and everything. This is interesting because this is actually one of the places where it calls out to the client because it's sending a response here, so it decides to pass some of that through CTTP. So it's not as clear as HTTP.c is Eyre and CTTP is Iris. There is some overlap with them, but basically HTTP is server, CTTP is client in those values there. Again, this is the kind of stuff that if you end up actually wanting to modify or upgrade Eyre or Iris, then you'll get down here in the runtime to deal with this stuff. Otherwise, libh2o and libuv just handle these directly for you. Iris, okay. It's HTTP client. We don't use it a whole lot because Urbit ships don't often act as clients, right? They're peers, not clients. And they only act as servers when you have a client session working with it. So it's not a common use pattern to use Iris. And it's sort of reflected by the fact that there's not a whole lot that it does. GIFs effects it can emit, right? So it can emit a request, it can emit a cancel request, it can emit a response. And then it has a few tasks which are basically reflected in that. There's a client response. Yeah, okay, so Nikolai says he's using it for the GET protocol. All right, so that makes sense. Like that is one place where your Urbit ship acts as a client. You could use it if you were doing forward proxy or reverse proxy stuff or CDN stuff with a ship, would make sense there. If you wanted a way to treat your Urbit ship as a browser to something else, which makes sense in some use patterns, then it makes sense. Yeah, I don't know. I mean, are you doing anything particular with it for the GET protocol? Or just like, this is how you make a request because you're acting as a client?
I mean, no, that's basically, yeah, just making requests. And it's very convenient to use, by the way. I'm using it through threads, actually.
Do we use this to retrieve the Galaxy table on boot? That's a good question. I think the Galaxy table stuff all takes place in the runtime.
Yeah, I don't think that Iris handles this specifically, but there's some
CTTP might get used.
Yeah, there are some ways in which like the Urbit, like even your Urbit ship needs to act as a client sometimes for HTTP. It needs to do this for like the. Go ahead, sorry.
Yeah. Do you remember if? Okay, I guess this is in Dawn.
Yeah, there's a bunch of RPC stuff that has to happen, like for the Galaxy table, for like checking your keys. Like I don't know if it uses Iris specifically, but it seems.
So it's post JSON. So you initialize your UV buffer. So it looks like we're doing everything through curl.
Mm-hmm.
So it's probably all in a library instead of being CTTP.
Mm-hmm.
So it's an equivalent sort of thing, but I don't think it's actually going through CTTP to do it.
You know, there's not like a unified everything, all HTTP requests that go through Urbit use this. It's like this kind of just uses some curl libraries or
Yeah, I
something
think,
that
and I
looks
mean, like we're building this really coarsely, right? Like we're actually just slogging some speed together to build this request. But I mean, that's what curl is,
right.
right? So
I was just curious. Thank you.
it makes sense, but it turns out we don't. There's several places in the runtime where you could imagine conceptually unifying operations, but for various practical reasons, we don't. Often driven by the nature of C or C libraries. So it's a good question, and I think you certainly could, but it turns out in practice we don't. Yeah, it sends progress reports, which is kind of an interesting thing. It knows how to send how many bytes it's read and how many it expects to read and what it's received recently. So you can send progress reports as a client when you're doing operations. And then finish is kind of your ACK. Like I've got everything. Iris is really short. So compared to the others, right, this 408 lines. I mean, even Eyre is like 3,000 lines. Ames was like 5,000 lines. So it's a small vein. It doesn't really scry anything. The only thing it scries actually is Way, which is your memory usage. It has no internal state other than that to really expose. It probably could. It does have the internal state of it knows about its IDs and its connections. So Nikolai asks, are these partial responses actually implemented? I guess that's a good question. It does have, it has a lot of things that refer to in progress requests. And these don't look partial to me. Like I don't think that's a stub interface. Yeah, like what all is to do'd in here? Okay, so we don't handle retries. We don't handle redirects or retries. We don't handle, so it's all retry stuff that it doesn't actually deal with correctly. Other than that, it looks like it's in decent shape.
So do you know if there's a way to like receive these partial responses from a thread? Because so far I've been using this like, you know, I just say I have a request and it comes back as a whole, say 100 megabytes response. I would like to have something which actually gives me incremental responses from the thread.
Yeah. It seems like you should be able to. I don't know exactly what that would look like. Because you might have to like chain threads together to get that to work. So I guess the question then is, let's see. So let's look up in progress HTTP request. So let's see where this is actually used outside of Iris. Okay, it's not used outside of Iris. So my guess is that Iris probably has a lot of functionality already built like this that just isn't really used because no one uses Iris. Right? Like the fact that this information is not scryable is very interesting.
So if I look at the, maybe that's not updated, but the docs on Iris say the progress and client and cancel client responses are not implemented.
Okay.
Maybe that's outdated, or I don't know.
I don't know. It's
I
very
find
possible that it's outdated, but it's also possible that it's correct. And what we have in here is just ambition. I don't know more than that though, other than I guess what we'd actually have to do is just like start using Iris. I've only used Iris once in a project. And that was for building a forward proxy proof of concept. So Nikolai, you've probably got as much experience with Iris as most people. Tinnis would probably know more about the state of that functionality. And other than that, let's see, CTTP pretty much wraps up what we need to say today. The main one here is the callback on a request body. And this is what H2O does the callback to when it gets a response. So when you receive a response, what do? And it's basically just pull in the value, consume the bits from the buffer, and then produce a response. Yeah, not a whole lot going on there. Builds these things. There you go. Right. That's your actual. Yeah. What is that? Line 727. You're all old hats at this.
Injecting a card, right, into the runtime.
Yeah.
Or
So
Novum,
that's,
I guess, specifically.
yeah, that's building your actual move injected into your runtime and putting it in. I've gotten a response. I need to deal with it, or a request, whatever I've gotten response, I guess. How do I deal with it? And there you go. That's what you do. Put it on your wire and send the payload. Yeah, that's we've seen this one a lot, haven't we?
Yeah, what's the deal with this? Well, I know it's an HTTP failure, but I've been seeing it a lot lately.
Yeah, this just means that you've gotten some number that's other than your 504. I don't know why I don't know what 504 is offhand, actually. 504 response code. I'm going to look this up real quick. List of HTTP status codes. 504 is a timeout. So if you get anything that's an error other than a timeout, you get an HTTP fail. So that could be internal server, not implemented, bad gateway. And I guess all of the 400s and 500s would go through there, except for timeout. So, yeah, I mean, Iris is, if the docs are correct, then it's kind of still in a baby state. Like it does some things that are necessary, but not others. A really easy project for someone would be implement proper scries for state. Like, can you actually get this information out as scries? Like that's probably like a 1 hour project. Maybe less. Because it's just putting in the what less for it. So if you want the contributor badge on GitHub and you don't have it yet, that might be a good one to take a look at. Yeah, so that's Eyre and Iris. That's Urbit as an HTTP server client. Other questions?
I've got a couple.
Okay.
One is sort of like, I guess, the whole Gall piece of this. We looked at this a little bit when we were looking at Spider and how threads are fielded. Like as requests, like if someone wants to send in a request via a thread, what that looks like. And I'm wondering, like, what does the infrastructure look like for Gall to, like, what does the interplay look like between Eyre and Gall to like forward those requests, like to send things to the HTTP or handle HTTP requests harm and that sort of thing? You know what I'm talking about?
Yeah. So you're saying basically how does
Like,
Gall how does Eyre get this to Gall?
That's right, yeah. Like, because Eyre will receive these things because these are fundamentally
Yeah.
HTTP requests, and then it has to forward them to Gall somehow. That's the piece I'm wondering about.
Yeah. So this is the request to app arm.
I see. Okay, so just in the Eyre vein, there's a request to app arm.
Yeah. So this is just we can see when it's actually called. That's your request local. But basically, if you get an action and it's an app action that you're binding, then you dispatch it to Gall. So you say, is it running? That's your GU. Does it exist? Does it run? If it does, then we're gonna manually send the yeah, we're gonna basically manually inject this through DLS. So we're gonna send a subscription. We're gonna subscribe for the response from Gall, and then we're gonna poke in that value as the handle HTTP request. So that's where that value actually comes from there.
I see. Okay. So it just generates a poke card?
Yeah, that's I should let me just add that to the notes because that's a good one that I kind of skipped lightly over. So that's what's going to happen here is we're just doing this our app poke, like we're just directly building this thing here and injecting it there. What else is worth?
The other thing I was wondering about was
Yeah, there's your DLS.
Oh, sorry.
So this is where that actually goes to Gall.
Oh, and the task is that card that we constructed above.
Yes. So request to app gets the value through an action and then constructs it and then dispatches it to DLS. And then this is what actually sends it to Gall.
Right. Okay, that makes sense. So this is actually, that task is a poke that we're going to say, like, here's the HTTP request, and then it'll handle it. That it'll receive that card and then process it.
Yes.
Okay. And the other thing I was wondering about was I was looking a little bit at Iris for one of the homeworks, and there's like a note inside there about it felt like it was related to like the sending of the cards in specific. Like kind of how the process works is that Iris will produce a card that's like in some ways intended for the runtime or for Arvo or however you want to look at that, which will then get filtered down into there. And then we were looking at some of those functions like CTTP, CREC on body. But there's a note, maybe this is related to Mikolai's question about like, there's a note about like either partial requests or about like something. There's like something very strange with how they're handled where like somehow it feels like there might be something about the way that they're handled right now that isn't ideal or optimal, and I'm not sure what that is. And I was kind of wondering if you had
Which
any
file is
insight
this
on
in
that.
again?
Oh, Iris. Iris.whom or Bane Iris.whom. I think if you just like control F for like request, you should be able to find it in there. Something about like wherever it handles these, like maybe send request or something. Yeah, I think just a little bit down from here. Yeah, right here.
This part.
There's
Okay.
yeah, there's a note here about
All right. The original Eyre keeps track of the duct on born and then sends a give on that duct. This seems like a weird inversion of responsibility where we should be doing a pass to Unix. The reason we need to manually build IDs is because we aren't using the built-in duct system. Okay, so Eyre creates a duct on born and then sends a give. Okay, so at least what 132 and 133 seem to mean is that you're creating a duct out to Unix,
mhm.
and then you're giving along that duct rather than passing along that duct. So Unix is getting a response, but there's not a corresponding request to which it is a response. Does that make sense?
I think so. Isn't like so I guess the semantics between give versus pass are a little maybe I don't understand them fully. Like it sounds like almost could you explain that again? Sorry. Like with like it's using a give and not a pass.
So a pass means that you are the originator of a request and you are generating a duct, which is a causal event sequence as it moves towards its endpoint.
Right. Mm-hmm.
And if it results in a value back along the duct until it arrives back at the originator.
Mm-hmm.
Unless you do something weird like a slip, because you're trying to fake it out.
Right, right.
Here what's happening is we are giving a value to Unix, but we are actually the originator.
I see. So like yeah, I guess yeah, that's very strange. It looks like that's the same thing that's happening here. We're like giving a request card, which is I don't know why we'd be giving one to Unix. Given that
Right,
like
and that's what it's saying here is it's saying why are we giving? We should be passing.
Mm-hmm.
Like logically we should be passing, but it looks like there's some technical reason that that's actually hard.
Mm-hmm.
I don't know what that is because I'd have to turn on git blame and figure out even what date this comment is. But that's an interesting one there.
Because I was just like trying to trace back like through the runtime, like where requests going, like how does it send a request, how does that get handled by Eyre and so forth. And then I came across this and
yeah,
because that pattern seems okay. Like generally speaking, the pattern of like generating a card to then be handled by the runtime seems like I don't know, like this seems like a reasonable way to handle it. But I see here that it doing a give instead of a pass seems weird. I don't know why exactly that's happening. Yeah. So okay, just was curious. Thanks for looking at it and giving some thoughts on it.
yeah, I'm not completely sure why this would be hard, but and I'm not actually sure why we can't just do a pass. Yeah, like that doesn't. It's not intuitive to me why this would actually be hard.
Because I guess the way in which it's handled, like there's no, maybe it still uses the same duct because it's kind of like just two cards are generated by two different things, and I don't know that there's a real association between them, as there would be with a pass, where you have like the wire that sort of shows the sequence over how this thing propagated through the runtime. But anyway, I don't know.
Well, I mean, there's definitely weird things that turn up when isn't exactly the same sort of thing, but it's sort of like the trouble you run into where like when you wake up a vein for the first time, sometimes you have to like slip because you want to make sure that the response comes back to a different vein than, you know what I mean?
Mm-hmm. Mm-hmm.
Like I think it's just, like there's shenanigans you have to do sometime to make sure that your response ends up in the right place.
Mm-hmm.
And it's
Yeah,
not
that's-
really like obvious unless you've actually been down in the weeds trying to solve that problem. It's actually hard to figure out why it was a problem.
Right. Yeah.
So
Like I don't
unless
know.
someone documented like exactly why this was hard, then it's not clear from the outside why it's hard.
Right.
I mean, I believe that it's hard if they're telling me in the
I do too. But yeah,
this
it'd
is
be
like
interesting.
the copy pasta about the number of hours that have been spent trying to solve this function.
Yeah. It would be interesting to pull on the thread of that, like like I might like get blame later and see who wrote that, and it'd be interesting to see those email threads and so forth. But at any rate, yeah, it's just more of a curiosity than anything. Thank you,
Yeah,
Neil.
let's see. I don't know if I have the tooling turned on to turn on get blame with extensions here, but I probably don't. Anyway. All right.
No.
Any other questions? If not, then I think we'll go ahead and wrap for today. Next week, Clay.
That'll be a big one. All right, thanks, Neil. See you next
Clay's
week.
going to be another big one, and there's a lot of future of Clay to talk about too, because there's at least two extremely different directions that Clay has been discussed going. So, all right, see y'all.
Yep. See ya. Thank you.